Recording is rolling. It is Tuesday, September 24th. All right, so update on projectile quizzes, which I know most of you guys turned in about a week ago. I want to get this back to you guys. I'm still waiting on a few from each type of class I have. So if you haven't turned that in, double check focus, make sure you have. If you haven't, then please get that in pretty soon. Your classmates wait for your quiz to get back. All right, so today is Friction Lab. You guys have on your desk or this page right here. Right. This Friction Lab is going to be 2 halves. I'll do a quick rundown with you guys. Right. Now, guys, on the back side of this paper is the Atwood Lab that I want to do later this week. So at the end of class today, just go ahead and hold on to this paper, and we're going to save this for later this week. Hopefully, we'll get hit by that hurricane. We're going to see. I think we'll be all right. All right. There's also, guys, on your desk, I did put the AP style rubric for the Friction Labs. There's 2 halves. There's the spring scale half where all you need measuring tool. There's only one measuring tool, the spring scale. And then on the other side, you can also determine coefficient of friction with the protractor. Talked about this a little bit yesterday, right? So normally I should have you guys write this up, but we'll do this a little bit different day because I know yesterday there was that reunification. We missed a little class. I looked back at the recording and it looked like it wasn't too bad, but there's just a few things I want to fill you guys in with, and then I'll send you guys off on this lab. Okay, you guys got that? All right, so I'll put the screen here. Oh, all right. So guys, on Google Classroom, here's your Google Classroom. Right, just want to point something out here real fast. If you scroll back to the beginning of this unit, you guys see dynamics, puzzles, and labs. All right, so there's a bunch of upload documents here. There's oh, hey, look, set free body diagrams, PowerPoint. There's some lab pages. If you scroll all the way to the bottom, I just uploaded these over the weekend, is your guys' chapter 4 puzzles. Now, guys, there's 2 files. There's 2 parts, part A and part B. You guys see that? Right? All right, so part A is like warm up. Here's all these solutions here. Oh, look, it's all your solutions to your textbook puzzles, like that. Right? And then, no, this is just part A, the warm up. And what you'll see if you look through is that a lot of these are, I think all of them fall into the categories of the posters that I put together for you guys. Like doesn't that look like the 2 spring scales held at diagonals? It looks like I've got, oh, hey, look, there's the chain gang. You guys like my monkeys? What's going on? We got, what else we got? Okay, different forces and vectors. Right. Oh, there's a hockey puck, I think, slowing to a stop. It's like a car braking to a stop. Here's your guys' part B. Look at all these. There's what looks familiar here. Right, there's force vectors. There's, I'm looking for, oh, okay, this one looks like that again, right? There's an elevator. Hey, elevator physics. That's one of the posters. A bucket being pulled up. That's kind of like an elevator. Ooh, look at that. There's a combination of Atwood and an incline. Ooh, that one looks fun. I forget if I circled that one or not, but if I did, that's pretty all encompassing there. All right, so there's all those. All right, let's also look at, because I wanted to flash some of these posters up yesterday. I'm going to do a quick rundown of these, right, just so you guys can see the broad picture of how these are organized. You guys got variables and units here, more variables and units. You guys got Newton's laws of motion, 1, 2, and 3. Know those, of course. Newton's laws of motion. Acceleration is bridging kinematic motion, and now Newton's second law of motion is dynamics. Got that. You guys know Hooke's law. That's your spring scales right there. We made a bunch of free body diagrams last week through some of the main ones up here. Guys, here's the first half of your lab today. All right, so can you guys have this free body diagram in mind? All right, so this is one of the main posters today. I got it right over there by my lab closet door. Okay, so guys, be thinking about this. And if you get a free response question from AP, be ready to draw all that, right? Label all the forces exactly what they are. Right, moving on. Right, coefficients of friction, you guys are going to find today between the surfaces. Oh, here's the other main one. I'm really glad I got this in your guys' note. This is in your notes from yesterday before you guys were sent to reunification. It's good to draw this out on paper a few times. This takes some practice. It takes some practice. Guys, equilibrium, there's only 3 forces on this object: the weight, the normal force, and the friction force. Right? Then introduce a Cartesian system, the weight, break into components, and think about it in terms of that. Guys, is the normal force always going to be equal to mg cosine theta? Yeah, as long as it's pretty straightforward like this. There's no other crazy forces going on. Right, and this friction force, you guys see this for equilibrium. For equilibrium, isn't it true this friction force would have to balance out with the mg sine theta, so it's the same magnitude. Okay, right. There's there's a few of these inclines. Right? Now, zero friction is like, hey, zero friction. Could that be your Hot Wheels car going zipping down? Here's how much your Hot Wheels car was accelerating down. What variable canceled out? The mass of the car. Mass canceled. Right. Take a look at that. Here's your net force, mg sine theta. Right. But that's not what you guys have today. Today, when you guys have an incline, you're trying to find coefficient of friction, which is definitely not frictionless. Right? Does this one look a little more complicated? Guys, if I toggle back and forth, at a glance, it's kind of hard to tell these two apart. You guys see that? You guys see this friction force popping up here on the friction one? I'm toggling back and forth. You guys see that? Right? Here's no friction. There's only two forces, weight and normal. Here's with friction. Now there's three forces. Right? There's a proof here. I'm pretty sure I've seen AP ask exactly this question before in the past, and they expect you to write out this entire proof just like this. Right? So guys, this one again, take some practice. You'll get some practice today because this is the second half of your lab today. Okay, I'm kind of spoiling it, but it's good to see it and see if you can come up with this whole thing from scratch, which is on a blank piece of paper. All right, also got here. All right, got some other free body diagram. Hey, it's the chain gang again. There's the monkeys. I'm fine. We got elevator physics, guys. Here's another huge. This is a huge category of physics questions right here. Is elevator physics. If you're in an elevator, now here I'm showing upward accelerating elevator. There's this proof, guys. Be ready to write out this whole proof. Again, there's some physics puzzles straight from your textbook. You're gonna see this several times in say different contexts. Okay, guys, be ready to write up a proof like this. I'm writing the normal force here, like if you're standing on a scale, but this could be the tension force. Say if there's a cable holding up the elevator, it's the exact same math. And then I've got all three situations: accelerating down, up, or accelerating. Right. In a couple of days, I want to do this lab with you guys. Got a classic Atwood, pulley, string, lab weights. Is it? Right, there's some math here. Of course, we'll solve some of these from a textbook too, but just give you guys the big picture right here. There's also a modified version. What if I take one of these, put on, say a Hot Wheels car, put a mass there. Okay. Do you guys see that the weight of this one is canceled out by its own normal force? The weight cancels out, but does it still have a bunch of mass? Still has a bunch of inertia? You think, but if it's a huge mass here, it's still slowing the system down a bit, right? Even though its weight cancels out. Right? You think about that. What's we got going on here? Here's a category question. I just scrolled through the solutions. Did you guys see a bunch of solutions that looked like that and were like that, right? Like some version of that, straight from your textbook. That one's fun. We'll like to do that with you guys. Car brakes to stop. Here's another classic one. Guys, what variable cancels out by the time you get to the end of this proof? The mass of the car. Goodbye. Right. So if you have an empty car or a car full of groceries and they break at the same time, are they going to break at the same rate? You think they'll take the same amount of road to come to a stop? That's an extension question that's going to come up when we get to conservation of energy. You'll see a completely different set of math, but it's completely consistent with this. Right. We got. So my students were telling me yesterday. I know. I remember this. This was a. This is a military entrance question. They'll ask you, what are the four forces on a plane to keep it in constant velocity? Okay. Constant velocity, zero. Is that, guys, that's zero net force. The two horizontals cancel, the two verticals cancel, right? So the military asks you that. Now you know, you've seen it. This drag force, I think is good to know. Here's a little bit thing point out. Do you guys see drag force is proportional to the speed squared? So the faster you're falling, maybe the more the drag force builds up. That's going to continue until the object reaches what kind of velocity? Terminal velocity. Guys, do you need an air drag to reach terminal velocity? Yep. So it won't happen in a vacuum, right? But you need an air drag. Is that trick? Get that. What's about this? I don't think you'll see too many questions about this, other than I do remember when I was taking college classes, this equation did pop up a few times. So maybe if you see it in college. All right, so there you go. Coefficients of drag, different shapes. This one's good to think about, but again, trying to zip through. Here, real fast. Right, so guys, drop something from edge of a cliff. If there's a tiny amount of air drag or no air drag, velocity versus time. If I asked you guys to draw that graph, would you just draw a straight line, and the slope would be the free fall gravity g? Right. But if there is air drag, is it eventually going to asymptotically reach terminal velocity? Then you can put it all together, and it's going to look like that. All right, let's we got. All right, there's a quick rundown of stuff. Otherwise, you would have missed from yesterday. All right, so switch back over here. All right, so give you guys the rest of the class. Remember, go ahead, do the two halves of this lab. You guys got your lab page. Okay. Yeah, make the best use of time. I'll walk around, help you guys out. Hold on to this page at the end of class for the Atwood lab later on.